So, thank you very much for inviting me to these talks. I'm glad that I can present you my slides about AI hallucinations, and hopefully, you will find it informative and interesting. So, let's dive into this very controversial topic. Here is first something about me. Well, you know me, what I do. In context of this talk, it is important that I have practical experiences with different large language models, almost from the day when they became publicly available here in Europe. So it's like 2 years already. And if you want to follow my articles, here is address on medium.com where you can find my works. Uh, Before I dive into this topic, I want to thank my colleague Felix Alipas-Dicke, who critically reviewed this presentation and gave me very valuable feedback and many ideas for this talk. And he is very knowledgeable about AI, so don't hesitate to ask him. Here is a list of topics I want to show you today. And as you can see here, I also created some pictures generated using AI to Deep Dream Generator to illustrate these slides better, make them hopefully more interesting. So, what are AI hallucinations? I think you all know the famous answer 42 from the book The Hitchhiker's Guide to the Galaxy. And by my opinion, this is actually the first ever recorded AI hallucination. Maybe it's even the ultimate hallucination on the ultimate question of the life, the universe, and everything. So, this is something we all already encountered. Problem with hallucinations created by current large language models is that they seem very plausible, but can be factually incorrect or contain completely fictitious information. So AI can generate hallucinations in text, images, videos, and some types can be even deliberately created to harm someone. So, if we are talking about normal hallucinations, they can cause some confusion or dissatisfaction. But if we use them blindly, they can even lead to serious legal or financial issues. There are already some cases documented in literature. So, if we use large language model, we communicate with it using texts, and we get the answer as text back. And these answers are always grammatically correct, then they sound plausible and confident, use proper language and terminology, so they sound highly believable. But problem is that they may contain facts which are borrowed from similar topics and are not exactly applicable to the current context, or can include entirely fictitious information. So we need to remember that plausibility does not guarantee truth. And very special type of AI hallucinations are so-called deepfakes. Those are deliberately created videos or audios or pictures which depict people in situations they never were in, or depict events which never happened. And usual goal is to manipulate public opinion and spread fake news. But the same tools can be also used for entertainment, like bringing back dead actors back into movies. So everything depends on the context and purpose. We can also look at those hallucinated texts as a source of creativity, because we can use this potential for brainstorming to create new ideas or concepts. And my daughter even uses ChatGPT for creative writing. But the problem is that AI hallucinations can pollute the web. Because not everyone verifies information before shares it, and some articles can be even published automatically by AI without human supervision. And later, people can copy paste that content without really double checking it. So, over time, these AI generated hallucinations can spread over internet and pollute it, and can be later used to train new AI models. So that problem can amplify over time. And because it could be problem both text and pictures, let's look at mechanisms how these hallucinations are actually created, so we understand better what is behind these things. First, if we would talk about pictures, we have so-called generative adversarial networks. Here is like typical topology of such thing, and it consists from two neural networks. First is called generator, and task of generator is to create new pictures using real pictures and some random noise. And this generated picture is later processed by discriminator, and discriminator tries to distinguish if that picture is real or is it fake. So these two neural networks, they are trained together in a so-called zero-sum game, and they tried to, outpower each other. So there are in real context to be better than that other network. They are amazing for generating images and videos, but were not that successful for generating text when compared to Transformers architecture. And hallucinations occur when there is a disbalance in this system. Either discriminator is too weak to find out that picture is actually fake, or generator is unable to generate like realistically enough looking picture to fool discriminator. So they constantly try to outsmart each other, and therefore this system is inherently unstable. But it works well for images and videos, and if you try it early AI tools for creating pictures, you could see many of these hallucinations like distorted bodies, body parts, strange amount of legs, arms, fingers. But in these days, it is much better. So this was about pictures, and now let's look how those hallucinated texts are being created. We must understand that AI hallucinations are not any errors or bugs. They are natural consequence of the way how AI works. It's like product of AI probabilistic reasoning. Because large language models generate answers based on probabilities learned from training datasets. So they gathered advanced statistics from training data, and based on input, they generate answer which is the most probable one, but not necessarily the correct one. Because for a large language model, there is nothing like correct or incorrect answer, only different answers with different probabilities. So when we try to summarize findings about these hallucinations, there are several mechanisms which can lead to hallucinations. First of them is called overgeneralization. As I said, LLM learns patterns and associations from training data, and training data set inevitably contains many biased data. And we may even overlook it because we think that it's something normal, but LLM finds all these biases. Very simple example is if we would train LLM with pictures which would always show cats and dogs together, LLM may conclude that these two animals live always together or that they are actually two forms of one species. So a model behaves here like a student who learned from a biased one-sided book, and his knowledge is distorted because of this. Another problem is called underfitting, and it happens if model is too simple or training dataset was too limited or training process was too short. In all these cases, models uh, cannot catch enough details, enough detailed patterns, and learns only very shallow relationships. And it leads to very vague and overly generic answers. And when I tested open source locally running models, which were highly quantized, which is one technique for shrinking size of the model, I got a lot of these overly generic underfitting answers. In this situation, a model is like a student who learned only very basic concepts and tries to really fudge the answer because he or she lacks detailed knowledge. On the other side of underfitting, we have overfitting. It happens when a model becomes too specialized on the training datasets. It learns all that noise and overly specific details and performs amazingly well on training data and repeats exactly phrases from the training dataset, but fails on new, previously unseen data. Problem is that training was too long and validation performance degraded. And we can imagine this situation like student who memorized some textbook and now uses this knowledge from this one textbook for everything, but cannot apply it for new problems properly, simply because it's too stuck on this knowledge. There could be other problems, and the biggest issue is if we input question which is ambiguous or incomplete. In that situation, it can lead to so-called overinterpretation of the input, and a model can try to fill gaps in the input by making the most probable assumptions, most probable based again on the training data. So it sorts of hallucinates missing parts of the input, and it can very easily lead to more hallucinations in the output because we did not give it precise and clear request. And another problem, which is happening very often for a very specific technical or scientific topic, is so-called out-of-distribution generalization. So training data sets are huge, but they are never complete, and some topics and areas will be underrepresented in that training data set or not covered at all. And exactly in this situation where training data set did not contain some specific topic, uh, we encounter this out of distribution generalization because in such situation model can only theorize based on some vague associations from data, so behaves like a student who tries to answer a question he or she never heard about before. And this can really happen for very specific technical topics. And I also encountered it several times when I asked very deeply aiming questions about Postgres database. So it was all about problem with training datasets. So let's look better on this issue. As I already mentioned several times, training datasets are huge, complex. It is also costly to collect them, and they are gathered on internet from books, from articles, whatever sources are available. But inevitably, the datasets contains errors, biases, inaccuracies, different topics represented with different frequencies. And those datasets are also static and reflect the state of the knowledge at the time of collection. And because training can take weeks, maybe even months in some situations, they can get outdated. Another problem is problem with understanding human languages. And I think we know very well this practical problem from our normal life. So imagine how difficult it is for a mathematical neural network to deal with this. Because human languages are complex and ambiguous. The same word can have different meaning in different contexts. Same concepts can be expressed in many different ways, and semantic associations shift over time. Best example in these days is the word cloud. Some 15, 20 years ago, cloud was only that fluffy thing on the sky, nothing else. In these days, majority of references to the cloud is about internet computing. So to explain this shift can be very difficult. And also regional and cultural differences in meaning of words affect language usage. So even language like English, which seems to be like quite standardized, has regional differences. And these things can lead into errors in understanding. Also, another problem is that if training data set is not sufficient for training a new model for some topics, researchers have to create synthetic data. And of course, they use previous models to generate these synthetic data sets. And here comes the problem with all those errors and biases which were fed into previous model and are now passed over to the new model for training. So such low quality synthetic data can even harm performance of the new model. So as we can see, that problem is quite complex. But I think enough science and all this stuff. Let's make it more fun. And I try to ask different AI models for some deliberate hallucinations. When I asked for 3 topics, I got mostly funny and creative results. But when I wanted them to hallucinate about technical or scientific facts, first results were like very obvious. No one would think that this is true. It was like really too simplistic. But after several iterations and some explanations, I got finally answers which were very confusing and quite difficult to decide if it's hallucination or not. So let's look at it. Here are just 2 examples of 3 deliberate hallucinations. First of them represents some funny, creative sentences, like in this case, in 1912, a group of mathematicians in Vienna discovered a formula that accurately predicts the taste of all types of cheese based on the angle of sunlight at noon on the summer solstice. Yeah, well, it sounds like from Hitchhiker's Guide to the Galaxy or similar type of books, and we can have fun with this and create some funny stories with sentences like this. And no one will think that this is actually true, but we will entertain it. But second, a hallucination is more difficult to uncover. It says that in 18th century, composer Ludwig van Beethoven collaborated with Pablo Picasso to create a series of musical paintings that depict the sounds of thunderstorms in oil on canvas. That second part, like musical painting depicting sounds of thunderstorm, in these days, artists use similar language, so it may sound like some artistic hype to like advertise some specific art. So we would take it as some artistic license. But that first part, Ludwig van Beethoven collaborated with Pablo Picasso. Yeah, in the case of these two guys, we know that they couldn't meet. But if there would be some other names who lived closer together, yeah, we might have problem to distinguish that this is actually not true. I think nice examples. AI created a lot of such examples. Just try. But as I said, I also tried to get some technical hallucinations to demonstrate how difficult it could be to distinguish true information from hallucinated text. And here are just three examples. All three contain a description of some features which are actually taken from other databases, but AI put them into context of Postgres. So those three texts are hallucinations, but looking at them, they are also very interesting inspiration for further development. Like, here Postgres full text search engine leverages neural network for semantic understanding and context-aware search results. Wow, I think clients would be thrilled to have something like this. Or reinforcement learning to optimize query execution. This would be something. It would be amazing. Or this automatic partitioning. So yeah, those are hallucinated informations. Some people could have a real problem to say if this is true or not, but it also shows that it could be an inspiration. And talking about inspiration, I decided to ask AIs to hallucinate about the causes of AI hallucinations. And I got quite an interesting spectrum of answers. Some models generated highly creative and really intriguing ideas. Other produced more grounded and realistic theories, but it was good fun. So let's look at some answers. Many times, models used words like quantum, subconscious, and all this stuff. So their answers sounded like some papers from a quantum physicist. First hallucination I want to show is this. AI hallucinations are caused by so-called quantum pigeons, which exist simultaneously in all states of error and correctness. And these quantum pigeons nest in the latent space of neural networks, causing probabilistic distortions that lead to hallucinations. Whenever the AI makes a mistake, it is because a quantum pigeon collapsed into reality where the correct answer does not exist. This is amazing. This is amazing quantum technical bubble, like for Star Trek or whatever science fiction movie you can imagine. We could take it and write the whole book about it. Amazing inspiration. Another answer was AI hallucinations are caused by quantum entanglement between the AI model and the user's subconscious mind. Wow. Looking at latest discoveries in quantum physics, this could be actually a valid theory like 10, 20 years in the future because, they tackle exactly these topics. Another very interesting and creative hallucination was that AI hallucinations are a result of linguistic gravity, a force that pulls certain words and concepts together based on their semantic weight. Just as masses distort space-time, complex words with multiple meaning create gravitational fields that pull in unrelated concepts. And when linguistic gravity reaches a critical point, it forms black holes of misinformation from which no accurate data can escape. Because I had also talked about AI prompt engineering and semantic associations, I enjoyed this answer very much because, semantic associations are the most important part of large language models functionality. So, again, sounds like very interesting scientific concept. And the last example I want to quote here, AI hallucinations happen because the AI is trying to look into its own mind, like a mirror reflecting itself indefinitely. This creates an endless loop of reflection where the AI loses track of what is real and what is a reflection. The more it tries to find the truth, the deeper it falls into its own hallucinatory loop, creating infinite echoes of errors. Yeah, well, amazing. We have alternate universes here, alternate realities. Yeah, again, you can use it and write amazing stories about it. Later, when I worked on these slides and also on article about these topics, I actually decided to ask AI again, and I used those hallucinations I quoted here, fed them into several models and asked them for some comments. And then I started discussion with them, and I particularly liked this one comment, which I want to quote. It was created by a large language model. It shows very nicely, like summarizes very nicely what I want to also tell you here. It says AI hallucinations aren't any random gibberish. They are rooted in the training data, making them not only a mirror of our present world, but also a window into our future possibilities, and maybe even giving us better understanding of aspirations and unresolved questions of our own society. And this is it. This is what we need to understand. No matter what AI gives us as the answer, it is always based on training data. So quality of training data and quality of our question are paramount here. But it's nothing like randomly artificially created. So it's really like mirror of our current understanding and knowledge. Now, in this context, I want also to talk shortly about deepfakes because it's like very interesting area, very dark area, very gray area. We have video enhancement techniques, and it's nothing secret. There are many video editors around, and they have advanced tools which can be used for enhancing pictures, like refine facial expressions, perfection of lip syncing, removing skin imperfections, also removing some objects or people from the background or adding objects or people. So this is normal stuff which is done in every post-production of every movie. But the same tools can be also used for the dark purposes, for creation of deep fakes. But in this part, I want to emphasize that entertaining use. So we have some already famous examples of deepfakes used in movies. So you probably have seen Princess Leia in The Rise of Skywalker. Carrie Fisher was added digitally there because she died few years before that movie was created. And they reused old footage and used some other person as body double and used CGI to create these new scenes in this movie. You probably also heard about Peter Cushing's deepfake in Rogue One. There was also young Princess Leia deepfake in Rogue One and young Luke Skywalker in the Mandalorian series. Those are like isolated examples of specific actors, but we also have the whole deepfake movie. In this case, the Lion King from 2019. It's a photorealistic remake of the old animated version of Lion King from 1994. And it uses photo references for designing everything and AI to mimic animals' behavior and give it a realistic look. And as they emphasize, the only real footage in the movie is the sunrise scene at the beginning. I watched that movie. I enjoyed it very much. Of course, we must look at it as a fairy tale and yeah, amazing piece of technology. I really liked it. So it was about those hallucinations, how they are created, how we can use them. And now let's dive quickly in the question how we can actually mitigate AI hallucinations in answers where hallucinations could be problematic. So, first of all, we must understand that hallucinations occur in all existing AI models. Because of those reasons, probabilistic reasoning, limited training data sets, and whatever, which I mentioned before, older models like ChatGPT 3 or 3.5 Turbo were much more prone to them. Also, if we try some locally running open source models, which are highly quantized, we will get really a lot of hallucinations. But newer commercial models like GPT-4 or GPT-4o produce fewer hallucinations. They improved really significantly, and also by using these tools, we can improve our techniques like prompt engineering and get better outputs. So we can't really totally eliminate hallucinations, but we can reduce them using those effective methods. And prompt engineering is the main tool we can use. So first of all, we of course must use the most reputable and most advanced AI models, but we must provide detailed and very specific instruction in the prompt. It's also best if we define which role AI should impersonate in that given task. Also, it's helpful when we limit output to some categories or topics which are relevant for that task. If we have some high quality examples as references, it's amazing. It can really help. And also we can exclude certain topics or categories explicitly. There is also this parameter called temperature, which is one of the parameters which we can adjust on different AI models. And usual value of this temperature is somewhere around 0.5, 0.6. And this value actually influence creativity of answers. So if we want to get like more precise answers, we can set that parameter closer to 0. But problem is the lower we set it, the more problems AI can have with generating the answer. So we need to find some sweet spot, and it looks like that zero point 0.5 is currently considered like an average sweet spot. So, by understanding all this, we must be sure that we double check all information which we get from AI, and especially if it's about these YMYL topics, your money, your life. So if we ask AI about some health, finance, safety, or legal issues and get some advice, we need to really double, triple check it because internet is already full of misinformation and fakes. AI generated text and generated videos now spread even more problematic information. So uh, it is best if we can to consult a human expert in the relevant field. Of course, we must hope that that guy will not just ask AI and give us the same hallucinated answer. But anyway, as always, we must double check. Not everything on internet is true. Not everything which give us AI is true. So it's our responsibility. We can't blame AI for some issues which we caused ourselves by using some information blindly. And that's it. I thank you very much. I really appreciate this opportunity to talk here. I hope you enjoy this too. And if you have some questions, I will stop recording and then you can ask. Thank you very much.